Okay, let's take a look at transformations. So I'm going to write an equation up here. It's not showing up very well there. Okay, y equals, and let's make it be a parabola. Let's make it be, 2 parenthesis negative x plus 1 squared minus 3. Okay, the first thing is you need to recognize what the parent is in this thing, and this looks like a parabola that's getting moved around. When it's an y equal x squared, it's a parabola. So it's called the parent, or yeah. And so I'm going to draw an axis on here, and I'm going to make a big deal about you need to decide what your unit spacing is going to be. So I'm calling each square 1. So I'm putting a 2 on the second line and 2 on the second line. And a parabola, 5 points that you should know for a parabola are 0 squared, 1 squared, and 2 squared is 4. Negative 1 squared is 1, and negative 2 squared is 4. And we're going to kind of try to follow those 5 points through the transformations. So now, because this is squared and everything inside the square, inside these parentheses, are going to affect the parabola horizontally. The stuff inside is a horizontal transformations. And everything on the outside of the parentheses, outside the square, is going to work vertically. So that's a vertical transformation, and that's a vertical. And you can choose, you don't have to do them in this order, but there is some order that is required to happen. I like to decide ahead of time whether I'm going to do vertical transformations or horizontal transformations. And so I'm going to start with the vertical transformations. And the vertical transformations, you do them in the order of operations. So if I had figured out what this number squared is, put in something for x, took the negative it and added 1 and then squared it, then order of operations say I should multiply before I subtract. And on the outside of the parenthesis, everything that works vertical works like you think it would. So, you do them in the order of operations, PEMDAS, some of you call it, order of operations. You multiply before you subtract. So you take care of the 2 first. And now 2 is multiplying by it, so you'd think everything would get twice as far from the x-axis. And this is critical that you think about twice as far from the x-axis, because if the graph was below the x-axis, it would go further down. If it was above, it goes further up. It goes twice as far from the x-axis. So since it's above and I'm going to stretch it some, I'm going to move my x-axis lower, leave my y-axis in the center, mark off that it's 2 and 2. Now 0, 0 is right on the x-axis, and twice as far from right on it is still right on it. At 1, it was 1 away, so it becomes 2 away at 1. At 2, it was 4 up, so now it's going to be 8 up. 1, 2, 3, 4, 5, 6, 7, 8. Twice as far from the x-axis as it was. So at minus 1, it was 1, so now it's 2. At minus 2, it was 4, so now it's 8. So that's what happened because of the 2 times on the outside of the parenthesis. So that's a vertical stretch. by a factor of 2. That's what the 2 did. Now, what's the negative 3 do? Well, the negative 3 is added on, or in this case, subtract 3. That's going to be a translation, and it's going to be in the vertical. So it's going to translate the whole curve down 3. And most of this you are familiar with. So I'm going to move my my x-axis back up 3, because the curve's got to go down 3. I'm going to keep the center line in the center. I'm going to say this is 2 and 2, so every square is 1 unit. And now 0, 0 goes down 3 to 0, negative 3. And 1, 2 has to go down 3, so it becomes 1, negative 1, and negative 1, negative 1. And at 2 over, it was up 8, so it's going to be still up 8, but that's down from the 8 here by 3, which puts it at 2, 5. And negative 2, 5. So the whole curve is down 3. Now, it's going to look the same as this because I moved the x-axis up 3. So this was a vertical shift or translation up 3, or down 3, excuse me. We moved it down 3, the graph down 3, the curve down 3, so I moved the x-axis up 3, but the curve moved down 3. Okay, now it gets to the tricky part. The stuff inside works horizontally, so it's moving left or right, or stretching or compressing left or right. And you are familiar that if it was forget the negative sign for a sec, if it was a plus 3, a plus 3, it moves at minus 3. If it's a plus 1, it moves minus 1. If it's a minus 1, it moves a plus. It's doing opposite. And if there was a number here like times 2, you would think it would stretch 2, but it actually compresses it by 2. And so everything works opposite, including the order in which you do things. Now, if I put a number in for x, order of operations says multiply by the negative first, and then add the 1. When you're doing transformations, you do them opposite of what it says to do, and in the opposite of PEMDAS, or the order of operations. So the minus 1 that's times this, we do it last. We do the plus 1 first. So plus 1, you would think it move it plus 1, but it moves the curve minus 1. So I'm going to leave my x-axis here, my y-axis here, make it 2 and 2 on the second line so that it's 1 square per unit. And I'm going to move everything, every point, each of these 5 points, minus 1. So at this one moves minus 1 to here. This one moves minus 1, so it's on the axis. This one that's 1 over goes to 2 over. And this one that was at up to 5 will go to 1, 5. And this one that was at minus 2, 5 will go to minus 3, 5. Each point gets moved 1. So this is a horizontal shift. One left. The curve is moved 1 unit left. Now, the minus on the x, a minus 1, if it was a minus 1 on the 2 on the outside, there would be two things here, a minus and a 2. The 2 stretched it. The minus would take everything that was positive, make it negative, and everything that's negative, make it positive. So it's a reflection over the x-axis. The minus on the inside is a reflection over the y-axis. So everything that's on the left goes to the right, and everything on the right goes to the left. So I'm going to leave my axes in the same place they were, and put on the 2 and the 2, and this point that's right on the curve is going to stay on the curve. This one that's 1 to the left will go 1 to the right. This one that's 2 to the left will go 2 to the right. This one that's 1 to the right will go 1 to the left. And this one that's 3 to the left will go 3 to the right. And it's a reflection over the y-axis. And that's what that negative on the x does. It's a reflection over the y-axis. Okay. So there's one example. Now, I might ask you, where the heck did, let's say, minus 1, 1 go? Minus 1, 1 in the parent function went to minus 1, 2, went to minus 1, minus 1, went to minus 2, minus 1, went to 2, minus 1. So can you track where each of the 5 key points go as we work through these? Okay, let's do another one. How about y equals 1/2 absolute value of negative 3x plus 1 minus, let's just leave it there. I think, is that all I want to do? Yeah, that's good enough. Okay, so now the parent function is the absolute value. And absolute value, you should know, is, I'll just put it here. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2. Absolute value negative 1 is positive 1. Absolute value negative 2 is positive 2. If those are my units on the axis, it would look something like this. It's a V. So that's the parent. That's what we're getting to moving around. So these are the 5 points that I'm expecting you to kind of follow through. Let's work horizontally first this time. So inside the parent is an absolute value. Inside it is the x. Inside the absolute value, we have a minus, a 3, and a 1. Outside, we have a half. So the half works vertically. Inside, we have the minus, the 3, and the 1. Inside, everything's opposite of what you think, and you do them in the opposite of the order of operations. So if I put a number in for x, you're supposed to multiply by 3 and the negative, and then add the 1. The 1 was last, so that's the first thing we're going to do. So that plus 1 works horizontally. You would think it would move it horizontally to the right, but it moves it to the left. It does opposite of what you think. So all 5 of these points get moved 1 to the right, left. Make sure my units are on the graph. A shift or a translation, 1 left. Then, now we're to the minus and the 3. And these are both times the x, the negative and the 3. So you can do them in either order. I'm going to do the negative first. So that's going to be a horizontal reflection, horizontally. So everything on the left goes to the right, and everything on the right goes to the left. It's a reflection about the y-axis. So let's see here. So that means if I put this on here, this is 1 to the left, so it goes 1 to the right. This is on the axis, so it doesn't move. This is 1 to the right, so it goes 1 to the left. This is 2 to the left, it goes 2 to the right. 3 to the left goes 3 to the right. So this is a horizontal HOR reflection over the y-axis. 2 and 2. So now let's do the 3. The 3, you would think it would make it 3 times as wide, but it makes it 3 times narrower. It's a horizontal compression by a third or by a factor of 3. I don't care which way you call it, but we're doing it not about the center of the curve, but towards the y-axis. This is where a lot of students mess up. A compression or a stretch happen relative to the axis. So this is going to look kind of strange and going to be hard to read here. So I'm going to look at this point. It's 1 away from the y-axis. I'm going to make it be 3 times closer. 1/3 as far. So it's going to be at 1/3. This point is 2 away from the y-axis. So if I do 1/3 of that, it's going to be at 2/3. This point, 3, 2, is 3 away from the y-axis, and 1/3 of that is 1. So instead of 3 away, it's 1 away. So you see how this side's getting pushed towards the y-axis. Now the other side gets pushed towards it. Now this is right on the y-axis, so 1/3 of 0 is still 0. This is 1 away, so it gets pushed to 1/3. And so my V is squeezed towards, towards the y-axis. Not on itself, but towards the y-axis. And now we have to do the 1/2. Now the 1/2 is on the outside, and so it does what we think it should do. It works vertically, and it makes it half as far from the x-axis. If some of this graph was below, it'd move it up. If some of it's above, it moves it down half as far from the x-axis. So it's a vertical compression by a factor of 2. So this point is 2 from the x-axis, so it moves to half as far, 1 from the x-axis, and that was at -1/3, 1. This was on the y-axis, but it's 1 away from the x-axis, so it goes to half as far. This one was right on the x-axis, so it stays on the x-axis at 1/3. This was at 2/3 over and up 1, so it goes up a half at the 2/3. And this was up 2 at 1, it was up 2, so it goes to up 1. So that's where those 5 points went. This is still 2, this is still 2. So if I said, where did 2, 2 go? 2, 2 went to 1, 2. And then we reflected it over the axis, so it went to minus 1, 2. Then it went to minus 1/3, 2. Then it went to minus 1/3, 1. All right, let's do one more. Let's do y equals, let's see, 3 square root of 2x minus 1 plus 1. So we have a parent function. It's y equal the square root of x. And there's only 3 points that I expect you to know on this. Keep track of. Putting my axis on here. The square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. It's half of a parabola. Okay. Let's see. Last time I did the inside first, so let's do the inside first again. Okay, so I'm going to work with the horizontal stuff. We got two numbers, the 2 and the minus 1. Order of operations say multiply by the 2 and then subtract the 1. Since it's inside, we do everything opposite. And the subtract 1 would be the thing we take care of first. And subtract 1, you would think it would move it left, but it moves it right, 1 unit. So since this point will go off the graph, I'm going to move my y-axis over to there. 0, 0 stays. We're moving everything right 1. So 0, 0 goes to 1, 0. 1, 1 goes to 2, 1. And 2, 4 goes to 4, 2 goes to 5, 2. Over 1, up 1, over 2, up 4. Okay, so this is a horizontal shift to the right 1. Now, I'm okay if you say just right 1 because that would mean the right, left and right says it's horizontal and you're going 1 unit. Okay. Now let's take care of the 2. So that means that, and the 2 times, you think it would stretch things out, but it's on the inside, so it moves things closer to the y-axis. So instead of 1, 0, it goes half as far from the y-axis, so it goes to a half 0. And this one's 2, 1 is 2 away, so it goes to 1 away, half as far. And this one was 5, 2, so it goes to 2 1/2, 2. And so that's a 2, that's a 2, and it's a horizontal, because I don't want to just say compression, because compression could go either direction. This is a HO horizontal compression, because it's squeezing it, by 2. Or a half if you want. I don't care. The factor is 2 or a half. Okay, now we go to the outside. We have a 3 and a 1. And on the outside, everything works in the order of operations. So we do the 3 first and then the 1. So we're going to stretch things vertically. I might go off the graph with that. So I'm going to move this one down here. I'm going to make this my X. And I put my Y in the same place. And this is going to be 2, and this is 2. All right. So now I'm going 3 times as far from the X-axis. This one's on the X-axis, so it stays on the X-axis. At a half, it stays there. This is 1 up, so it goes 3 times as far, so it goes to not 1, but 1, 2, 3 up. And this one was up 2 at 1, 2.5, it was up 2. So what? 2.5, it goes up not 2, but 6. 2, 4, 6. So this is a vertical, not compression, it's a stretch by a factor of 3. And then finally, we have to move it up 1. So I can leave my axes in the same place. And I can say vertically up 1, but up is in the vertical direction. So I'm going to say up 1. So this point that was at a half 0 goes to a half 1. This point that was at 1, 3 will go to 1, 4. 1, 2, 3, 4. And this point that was at 2.5, 6 will go to 2.5, 7. 1, 2, 3, 4, 5, 6, 7. Goes on, ends there. So, let's track a point. Let's pick the 4, 2. Where does 4, 2 go to? It went to 5, 2. Went to 2.5, 2. Went to 2.5, 6. Went to 2.5, 7. Okay?